April 15, 1943. In a heavily guarded naval research facility on the outskirts of Kure, Japan, a team of engineers huddled around a sleek metal cylinder resting on wooden blocks. Outside, cherry blossoms drifted across the harbor, where Imperial warships rested at anchor, their crews confident in Japanese naval supremacy across the Pacific. Commander Hideo Tanaka believed this captured American torpedo would reveal only primitive technology, confirming what military leadership had long assured them, that Western engineering remained far behind Japanese innovation. He could not have imagined how this single examination would shatter everything they thought they knew about their adversary. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the story of how a single technological revelation forced an entire nation to confront the uncomfortable truth about their opponent, and how the quiet work of engineers, not the thunder of battleships, would ultimately determine the outcome of the greatest conflict in human history. Commander Tanaka adjusted his spectacles as he surveyed the workshop. Bright overhead lights illuminated the 23-foot-long Mark 14 torpedo, its bronze-green housing still bearing scars from the recovery operation. The weapon had been retrieved from a failed attack on a Japanese convoy near the Solomon Islands 3 months prior. Most American torpedoes detonated or sank into the abyss after missing their targets, making intact specimens exceedingly rare. "Proceed with the disassembly," Tanaka instructed, his voice betraying none of the anticipation he felt. At 46, Tanaka had spent nearly 2 decades designing torpedo systems for the Imperial Japanese Navy. His team had perfected the Type 93 oxygen torpedo, widely considered the most advanced naval weapon of its kind, with speeds reaching 49 knots and ranges of up to 24,000 yards. The American torpedoes, by comparison, had been dismissed as technologically inferior, unable to match the range, speed, or reliability of Japanese weapons. Lieutenant Shigeru Nakamura, the youngest member of the technical team at 29, positioned himself at the warhead section. His hands moved with practiced precision despite his youth, having distinguished himself at Tokyo Imperial University before being recruited directly into naval engineering. "Beginning with external inspection, Commander." Across from him, Chief Engineer Ichiro Yamamoto, a grizzled veteran of 53 years with calloused hands and methodical patience, arranged the specialized tools they would need. Yamamoto had worked on nearly every torpedo design in Japan's arsenal since 1924. "We should document everything meticulously," he suggested. "Imperial Headquarters is most interested in the detonator mechanism." Recording technician Keiko Taniguchi, one of the few women permitted in this military facility, positioned her equipment. At 34, she had overcome significant barriers to earn her position, her expertise in technical documentation making her irreplaceable despite traditional gender roles. Her notebook lay open, pencil poised to record every observation and measurement in her precise, economical handwriting. The initial examination proceeded methodically. External dimensions were measured and compared against known American specifications. The Mark 14 was slightly larger than the Japanese Type 93, measuring 23 feet long and 21 inches in diameter, with a weight of 3,580 pounds. The Japanese Type 93, by contrast, was 24 feet long but only 24 inches in diameter, weighing approximately 2,700 pounds. "Note the welding quality," Yamamoto observed, running his weathered fingers along the seams, surprisingly consistent. "Far better than our intelligence suggested." Tanaka nodded, making a mental note. Japanese naval intelligence had repeatedly emphasized American manufacturing inconsistency, suggesting mass production had compromised quality. Yet the evidence before them contradicted this assessment. After photographing the exterior from multiple angles, the team began the delicate process of accessing the internal components. The propulsion section was the first to be opened, revealing the power plant that drove the torpedo through water toward its target. "Commander, you should see this," Nakamura called out after 30 minutes of careful disassembly. His voice contained a note of surprise that immediately drew everyone's attention. Tanaka moved to his side, bending to examine the propulsion system. What he saw made him straighten up slowly, his expression carefully neutral despite the sudden tightness in his chest. "The Americans are using a closed-cycle engine," he stated flatly. The significance was not lost on any of them. Japan's Type 93 used pure oxygen instead of compressed air to power its engines, creating a nearly wakeless torpedo with extended range. This oxygen system had been considered Japan's greatest naval secret and advantage. Japanese intelligence had insisted American torpedoes used obsolete compressed air systems, creating visible bubble trails and limiting their effectiveness. "How advanced is it?" Yamamoto asked, moving closer to examine the component. "Different approach than ours," Tanaka replied, "but the principle is similar. They've designed a system that minimizes wake signature while maximizing fuel efficiency." He pointed to a particularly elegant valve assembly. "Look at the machining quality. Every component is precision manufactured." Nakamura carefully extracted a fuel sample, transferring it to a glass vial. "I'll have the laboratory analyze this immediately." As the day progressed, the torpedo gradually revealed more of its secrets. The team worked through lunch, too engrossed in their discovery to break for food. By mid-afternoon, they had exposed approximately 60% of the internal components, meticulously documenting each one. Proceeding to guidance section, Nakamura announced, as they reached perhaps the most crucial component, the system that directed the torpedo toward its target. Japanese torpedoes utilize gyroscopes for straight-line navigation, requiring precise calculations before launch. Attacks typically involve spreading multiple torpedoes in a pattern to increase hit probability. This approach had proven devastatingly effective in the early war, particularly at the Battle of the Java Sea, where Japanese torpedoes had sunk several Allied vessels at extreme ranges. As the guidance housing was carefully removed, a reverent silence fell over the workshop. Inside was a complexity of components that immediately challenged everything they had assumed about American technological capabilities. "This is not a simple gyroscopic system," Yamamoto whispered, his usual stoicism cracking as he leaned in for a closer look. At the center of the guidance system sat a device unlike anything in Japan's torpedo arsenal. Tanaka's hands trembled slightly as he reached for his magnifying glass, leaning in to study the intricate mechanism. "It's acoustic," he finally said, his voice barely audible, "an acoustic homing system." The implications were staggering. While Japanese torpedoes required precise aim and traveled in straight lines, this American weapon could actually listen for its target, adjusting its course in response to the sound of ship propellers. It could chase a vessel attempting evasive maneuvers, effectively negating the defensive tactics Japanese captains had relied upon. "That explains the anomalous hit patterns," Taniguchi said, flipping through her reference documents. "Our naval reports show American torpedoes striking vessels even after successful evasive maneuvers. We attributed it to luck or exaggeration." Tanaka sat heavily on a nearby stool, removing his glasses to rub his eyes. The reality of what they were discovering was difficult to reconcile with the official narrative they had been fed. Japanese naval strategy had been built around the assumption of technological superiority. This torpedo suggested otherwise. "We need to continue," he said after a moment, replacing his glasses and straightening his posture. "Full disassembly and analysis." By evening, the torpedo lay completely disassembled, its components arranged methodically across several workbenches. The team had worked for nearly 12 hours straight. Their initial curiosity transformed into deep concern as each new discovery painted a more troubling picture. The warhead contained approximately 692 pounds of Torpex explosive, significantly more powerful than the Type 93's 550 pounds of Type 97 explosive. The detonator utilized a magnetic influence trigger that could detect a ship's magnetic field and detonate beneath the keel, the most vulnerable point of any vessel. "The craftsmanship is remarkable," Yamamoto noted, examining a precision-machined gear under bright light. "Look at the consistency of these teeth, perfect tolerances throughout." "Mass-produced yet precision-made," Nakamura added. "Our intelligence reports claimed American manufacturing prioritized quantity over quality, but this—" He gestured at the disassembled torpedo. "This suggests they've achieved both." Commander Tanaka walked slowly around the tables, taking in the full scope of what they had discovered. As Japan's leading torpedo expert, he understood the strategic implications better than anyone in the room. The Americans had not only caught up to Japanese torpedo technology, but had potentially surpassed it in several key areas. "The acoustic guidance system is at least 2 years ahead of our current research," he said quietly, "and their manufacturing quality exceeds our capacity in several areas." The room fell silent as the weight of his assessment sank in. Japan had begun the war with clear technological advantages in torpedo design, advantages that had contributed to devastating American losses in the early Pacific campaign. Those advantages, it now appeared, had been systematically erased. "What do we tell headquarters?" Taniguchi asked, her pencil hovering above her notebook. Tanaka considered the question carefully. Naval Command had repeatedly assured the Emperor of Japanese technological superiority. This report would directly contradict years of confident assessments and could be seen as undermining military leadership. "We tell them the truth," he finally said, "precisely and completely. The future of our nation depends on an accurate understanding of our opponent." That evening, as his team prepared their official report, Tanaka remained alone in the workshop, staring at the disassembled Mark 14 torpedo. The components represented more than just a weapon. They told a story about American industrial capacity, scientific advancement, and strategic foresight. He recalled the confident predictions made at the war's outset, that America's industrial base would take years to convert to military production, that their technology lagged significantly behind Japan's, that their fighting spirit could not match Japanese dedication. Looking at the evidence before him, Tanaka could no longer believe any of those assumptions. His thoughts were interrupted by a knock at the workshop door. Vice Admiral Takeo Kurita entered, his uniform immaculate despite the late hour. At 55, Kurita commanded significant portions of the combined fleet and had come to observe the torpedo examination personally. "Commander Tanaka," he greeted with a slight bow, "I understand you've completed your initial analysis." Tanaka came to attention immediately. "Yes, Admiral. The report is being finalized now." Kurita moved slowly around the tables, examining the disassembled torpedo components with a practiced eye. Though not a technical specialist, he had risen through the ranks during a period of rapid naval innovation and understood the fundamentals of torpedo warfare. "Your preliminary findings?" he asked, his tone neutral. Tanaka hesitated only briefly before answering truthfully. "The American Mark 14 torpedo incorporates several advanced features we had not believed them capable of producing. Most significantly, an acoustic homing system that allows the torpedo to track vessels attempting evasive maneuvers." Kurita's expression remained impassive, but his posture stiffened slightly. "Manufactured in quantity. All evidence suggests mass production. The machining quality is exceptional, consistent with standardized manufacturing processes rather than prototype or limited production." The Admiral picked up a component of the guidance system, turning it over in his hands before carefully replacing it. "And your assessment of how this affects our naval strategy?" This was the most difficult question, touching on matters far beyond technical specifications. Tanaka chose his words with extreme care. "Admiral, if the Americans are deploying these weapons in significant numbers, our current anti-torpedo tactics will prove increasingly ineffective. Additionally, the manufacturing quality suggests American industrial capacity has been underestimated." Kurita nodded slowly, processing this information. "I see, and how long would it take to develop countermeasures or equivalent systems?" "With current resources, developing acoustic countermeasures would require at minimum 18 months. Replicating their manufacturing precision would necessitate significant industrial retooling." The Admiral was silent for a long moment, his gaze fixed on the torpedo components, but his mind clearly elsewhere, perhaps on fleet deployments, resource allocations, or the broader strategic picture. "Complete your report by morning," he finally said. "I will personally deliver it to Imperial headquarters." He turned to leave, then paused at the door. "Commander Tanaka, this information is now classified at the highest level. Your team will speak of it to no one." After the admiral departed, Tanaka returned to his contemplation of the disassembled weapon. The Mark 14 represented something beyond its technical specifications. It was tangible evidence that Japan's strategic assumptions about American capabilities were fundamentally flawed. The next morning, Tanaka and his team presented their complete findings to Admiral Kurita and several senior naval officers. The atmosphere in the briefing room was tense, with occasional whispers exchanged between flag officers as particularly significant details were revealed. Lieutenant Nakamura guided the officers through the propulsion system analysis. The American Torpedo utilizes a modified closed-cycle engine that provides a 27% range increase over previous models while reducing visible wake by approximately 80%. Our laboratory analysis confirms they've developed a high-energy fuel mixture that approaches the efficiency of our oxygen system without some of its instability issues. Chief Engineer Yamamoto followed with a detailed examination of the manufacturing quality. Every component shows evidence of precision machining consistent with advanced industrial processes. Tolerances are maintained throughout, suggesting not hand finishing, but rather exact production specifications achieved consistently through modern manufacturing. When Tanaka presented the acoustic guidance system, the room grew noticeably quieter. He explained the fundamental operating principles, how the torpedo could detect the specific frequency signature of ship propellers, distinguish targets from background noise, and adjust its course accordingly. Based on our analysis, he concluded, these torpedoes can track a target executing evasive maneuvers at ranges of up to 900 meters, with the homing system activating during the terminal approach phase. Admiral Kurita remained expressionless throughout the briefing, but several other officers showed visible concern. Captain Minoru Genda, an innovative tactical planner who had helped design the Pearl Harbor attack, posed the first question. Commander, what is your assessment of American acoustic torpedo production capacity? Based on manufacturing evidence, these are not experimental weapons, but standardized production models, Tanaka replied. Our intelligence indicates deployment began approximately 6 months ago, initially in limited numbers but now appearing with increasing frequency. Rear Admiral Taman Yamaguchi leaned forward. And our countermeasures? Tanaka exchanged a brief glance with his team before answering honestly. At present, we have no effective countermeasures deployed. Theoretically, noise-making devices could confuse the acoustic sensors, but developing and producing such systems would require time and resources. The implications hung heavily in the air. Japanese naval superiority, assumed as almost a natural law since the stunning victories at Pearl Harbor, the Philippines, and the Java Sea, was being systematically eroded. And unlike the dramatic visibility of aircraft carriers or battleships, this erosion was occurring beneath the surface in the quiet realm of torpedoes and submarine warfare. After the briefing concluded, Admiral Kurita asked Tanaka to remain behind. When the room had cleared, the Admiral walked to the window overlooking the harbor, his hands clasped behind his back. Your report will go to Tokyo tomorrow, he said without turning. I expect it will cause considerable reconsideration of current strategic assessments. Tanaka stood at attention, waiting. You understand the significance extends beyond torpedo design, Kurita continued. This weapon contradicts fundamental assumptions about American industrial and technological capabilities, assumptions upon which our entire war strategy has been constructed. Yes, Admiral. Kurita turned from the window, fixing Tanaka with an evaluating gaze. Your team is being reassigned effective immediately. You will establish a dedicated countermeasures division with priority resource allocation. Your objective is to neutralize the acoustic homing advantage and develop equivalent or superior systems for our own use. Understood, Admiral. You have 6 months, Commander Tanaka, not 18. The Admiral's timeline was nearly impossible, given current resources and technical challenges, but Tanaka simply bowed in acknowledgement. We will not fail, Admiral. Over the following weeks, Tanaka's team expanded to include additional engineers, physicists, and manufacturing specialists. They were allocated secured workshop space at the Kure Naval Arsenal and given priority access to materials despite increasing shortages throughout Japan. The challenges they faced were formidable. Japan's industrial base, while advanced in certain areas, lacked the scale and standardization of American manufacturing. Critical materials were becoming scarce as Allied submarine attacks disrupted shipping routes. Even basic components required complicated procurement processes and often arrived late or not at all. Lieutenant Nakamura led the acoustic analysis team, working to understand the precise frequencies the American torpedo targeted and how its tracking system functioned in different marine conditions. Chief Engineer Yamamoto focused on countermeasure development, experimenting with various noise-making devices that could potentially confuse incoming torpedoes. 6 weeks into the project, Nakamura made a breakthrough during a late-night testing session in the harbor. Using underwater microphones to record the sound signatures of different vessel types, he discovered that the American acoustic system appeared specifically calibrated to target the frequency range produced by larger warships. "The homing system is remarkably sophisticated," he explained to Tanaka the following morning, pointing to acoustic pattern graphs spread across the conference table. "It doesn't simply track any noise. It's specifically designed to identify and home in on the unique acoustic signature of large propellers turning at combat speeds." This discovery led to their first potential countermeasure, a towed noise-making device that could mimic the sound of ship propellers, potentially drawing torpedoes away from actual vessels. Initial tests using small-scale models showed promise, and Tanaka authorized immediate development of full-sized prototypes. Meanwhile, efforts to replicate the American acoustic system faced repeated setbacks. Japan's electronics industry lacked key manufacturing capabilities necessary for the precision components. Materials shortages forced compromises that reduced performance. Even when individual components functioned correctly, integrating them into a complete system revealed compatibility issues that hadn't appeared during separate testing. During this period, reports from the front lines confirmed their worst fears. American submarines were achieving increasingly successful attacks against Japanese shipping, with torpedoes demonstrating the exact homing capabilities Tanaka's team had identified. In a particularly devastating engagement in June 1943, the destroyer Yugomo reported evading an initial torpedo spread only to be struck by weapons that seemingly followed their evasive maneuvers, a clear signature of acoustic homing. As summer heat blanketed Kure in humidity, Tanaka's team pushed forward despite diminishing resources and mounting pressure. Their workshop operated 24 hours in 3 shifts, with engineers often sleeping on cots between testing sessions rather than returning to their quarters. The Navy had constructed a small test pond adjacent to their facility where scaled torpedo models could be tested under controlled conditions, and the sound of small engines could be heard at all hours as various prototypes underwent evaluation. 4 months into their project, with Admiral Kurita's deadline looming, they achieved their first significant success. After dozens of iterations, Yamamoto's team developed a relatively simple countermeasure device that could be manufactured with available materials and deployed by vessels under attack. "We call it the Echo Maker," Yamamoto explained during the demonstration for naval leadership. The device, roughly cylindrical and measuring 1 meter in length, could be quickly deployed from a ship's stern. Once in the water, it would activate and produce acoustic patterns, mimicking a large vessel's propellers. In controlled tests, the Echo Maker successfully drew acoustic torpedoes away from their intended targets approximately 70% of the time. Not perfect, but a significant improvement over having no countermeasures at all. More importantly, it could be manufactured using existing facilities and deployed on vessels without extensive modifications. Admiral Kurita observed the demonstration personally, watching as a small-scale torpedo consistently veered toward the Echo Maker rather than continuing toward its original target. When the tests concluded, he gave immediate authorization for production and deployment, with the first units to be installed on critical fleet units within 30 days. The effort to replicate American acoustic technology proved more challenging. Despite their understanding of the principles involved, creating a comparable system with available Japanese technology remained elusive. After multiple failed prototypes, Tanaka made a difficult decision in late August. "We must adapt our approach to match our capabilities," he told his team during a strategy session. Rather than attempting to replicate the American system exactly, we will develop a simplified version that can be reliably produced with our existing manufacturing capacity. This pragmatic pivot yielded results. By reducing complexity and accepting certain performance limitations, Nakamura's team created an acoustic homing system that, while less sophisticated than the American version, could be manufactured with available technology and materials. The resulting Type 1 acoustic homing device detected targets at shorter ranges and with less accuracy, but it functioned reliably and could be integrated into existing torpedo designs. As their 6-month deadline approached, Tanaka prepared a comprehensive report for Admiral Kurita. The document detailed their achievements: the Echo Maker countermeasure now in production, the simplified acoustic homing system undergoing final testing, alongside an unflinching assessment of continuing American advantages in manufacturing precision and materials quality. The night before submitting the report, Tanaka remained in his office long after his team had departed. On his desk sat photographs of the American Mark 14 torpedo as they had first found it, alongside images of their own prototype systems. The contrast was unmistakable, a reflection of the fundamental industrial disparities between the two nations. Japan had begun the war with specific technological advantages, carefully developed and jealously guarded. What they had not fully appreciated was America's capacity to not only catch up, but surge ahead through sheer industrial might. A single examined torpedo had revealed this uncomfortable truth more clearly than any intelligence report or strategic analysis. Admiral Kurita received Tanaka's report on October 12, 1943, exactly 6 months after their initial examination of the Mark 14 torpedo. The Admiral reviewed the document carefully before scheduling a private meeting with the commander. "Your team has accomplished what many considered impossible," Kurita acknowledged as they sat in his office overlooking Kure Harbor, where warships now departed with Echo Maker devices installed on their sterns. "The countermeasures are already saving vessels and lives." "Thank you, Admiral, though our acoustic homing system remains less advanced than the American version," Tanaka replied honestly. Kurita nodded slowly. "That fact itself is perhaps the most valuable insight from your entire project, Commander Tanaka. We began this war believing our technological edge would compensate for American industrial capacity. Your work has demonstrated the fundamental flaw in that assumption." The Admiral rose and moved to a large map of the Pacific Theater displayed on his wall. Red pins marked Japanese-controlled territory, noticeably fewer than 6 months earlier as Allied forces advanced across multiple fronts. "The Americans are not just producing more weapons than us, Commander. They are producing better weapons, with remarkable speed and in staggering quantities." Kurita's finger traced the supply routes now heavily contested by American submarines, equipped with the very torpedoes Tanaka had studied. This is not merely a battle of factories or resources. It is a confrontation between fundamentally different industrial philosophies and capabilities. Tanaka remained silent, understanding the Admiral was speaking of matters far beyond torpedo design. "Your team will continue its work," Kurita continued after a moment, "but I have also forwarded your findings to Imperial Headquarters with my personal assessment of their strategic significance. Whether this will influence broader thinking remains to be seen." Indeed, the strategic implications of Tanaka's discovery rippled outward in the following months, though not always with the impact he had hoped. Some naval leaders embraced the evidence and advocated for strategic adjustments accordingly. Others, invested in existing doctrines and perspectives, disputed the findings or minimized their importance. The Echo Maker devices proved effective in reducing torpedo casualties, with Japanese naval losses dropping measurably in engagements where the countermeasures were deployed. The simplified acoustic homing system was successfully integrated into the Type 95 Mod 4 torpedo, entering limited production by early 1944, despite increasing material shortages and production disruptions from American bombing. Yet the broader lesson, that Japan's industrial capacity was being systematically outpaced, remained difficult for many military leaders to fully accept. Strategic planning continued to emphasize quality over quantity. special operations over industrial preparation, and the fighting spirit of Japanese forces over material considerations. For Commander Tanaka and his team, their encounter with the Mark 14 torpedo marked a profound shift in perspective. They continued their work with renewed urgency, understanding more clearly than most the true nature of the conflict and the fundamental challenges Japan faced. Their efforts saved ships and lives, but the industrial reality they had uncovered could not be engineered away. In September 1944, as American forces approached the Philippines, Lieutenant Nakamura was transferred to a forward research station at Subic Bay to assess captured Allied equipment. Before departing, he visited Tanaka's office to say goodbye. "I keep thinking about that first day with the Mark 14, Nakamura confessed as they shared a quiet cup of tea. "How certain we were that it would confirm everything we already believed." Tanaka nodded, remembering his own confidence that examination would reveal American inferiority. "Perhaps that was our greatest vulnerability, not our industrial capacity, but our certainty. Do you think things might have been different if we had understood sooner, if we had truly comprehended what we were facing?" The question hung in the air between them, impossible to answer definitively, yet impossible to ignore. "Understanding reality is always valuable," Tanaka finally replied, "even when that reality is not what we hoped to find." 2 weeks later, Nakamura's transport was struck by an American submarine torpedo while crossing the Philippine Sea. The acoustic-homing Mark 14 found its target despite evasive maneuvers. There were no survivors. By early 1945, the strategic situation had deteriorated dramatically. American bombers regularly appeared over Japanese cities, and naval blockades made material shortages increasingly acute. Tanaka's team continued their work under increasingly difficult conditions, developing simplified designs that could be manufactured with available materials and adapting torpedoes to use alternative fuels as traditional supplies dwindled. In March, during a rare meeting of technical team leaders from across Japan's military research establishment, Tanaka encountered Dr. Hideki Tamura, a physicist working on radar countermeasures. As they discussed their respective challenges over a sparse meal that reflected nationwide food shortages, Tamura shared an observation that resonated deeply. "The Americans have created an entirely different approach to warfare," Tamura noted. "They've industrialized it completely, removing the human bottlenecks and variability. When we examine their equipment, not just the designs, but the manufacturing methods, we're seeing not just weapons but their entire social organization reflected." Tanaka thought back to the precision-machined components of the Mark 14, each interchangeable, each produced to exacting standards at massive scale. "Their torpedoes chase our ships," he replied, "but their factories are chasing our entire way of waging war." As Allied forces drew closer to the Japanese home islands, Admiral Kurita visited the Kure facility one final time in July 1945. The admiral had commanded Japanese forces at the Battle of Leyte Gulf and had witnessed firsthand the consequences of American industrial superiority. He found Tanaka's team working on their latest adaptation, a simplified acoustic torpedo that could be manufactured with minimal specialized components. "Your work has been exemplary, Commander," Kurita said as they walked through the now sparse workshop, many materials having been redirected to more pressing defense projects. "Perhaps more important than you realize. Thank you, Admiral. Though our achievements seem modest compared to the challenges we face." Kurita stopped and turned to face Tanaka directly. "Not all victories are measured in ships sunk or territories captured, Commander. Sometimes understanding itself is the victory, even when what we understand is difficult to accept." In the aftermath of the war, as Japan rebuilt under American occupation, Tanaka often reflected on that conversation and the lesson of the Mark 14 torpedo. The examination had revealed not just an advanced weapon, but an industrial philosophy that had fundamentally changed modern warfare. Mass production had not compromised quality, but had instead democratized precision, making advanced technology available in overwhelming quantities. The Mark 14 torpedo, with its acoustic homing system chasing Japanese ships across the Pacific, had been emblematic of a larger pattern. American industry pursuing Japan with relentless efficiency, ultimately overtaking and surpassing what had once been considered insurmountable advantages. Many years later, as Japan's post-war economic miracle transformed the nation into an industrial powerhouse, Tanaka recognized elements of what they had discovered in that naval workshop in 1943. Japanese manufacturers embraced precision engineering, quality control, and efficient production methods, lessons learned partly through the difficult experience of witnessing American industrial capability during the war. The companies that would eventually make Made in Japan synonymous with quality, Toyota, Sony, Mitsubishi, and countless others, adopted and improved upon the very manufacturing principles that had once given American torpedoes their edge. The painful lesson of the Mark 14 had, in its way, helped transform Japan's approach to industry and technology. In 1972, nearly 3 decades after that fateful examination, Tanaka, now a consultant for Japan's growing electronics industry, visited an American manufacturing exhibition in Tokyo. Among the displays of modern technology, he found himself drawn to a historical section featuring military equipment from the Second World War. There, mounted on a simple stand, was a Mark 14 torpedo cut away to display its internal components. A small placard described its technical specifications and noted its contribution to Allied victory in the Pacific. Around it gathered Japanese engineering students, studying its design with professional curiosity, but no personal connection to its history. Tanaka stood back, watching as a new generation examined the torpedo with none of the shock or concern he had felt that day in 1943. For these young engineers, the Mark 14 was simply an interesting historical artifact, its lessons about industrial capability long since absorbed into Japan's modern manufacturing philosophy. As he turned to leave, Tanaka noticed an elderly American man also observing the torpedo display. Something in the man's posture, the way he studied the weapon with knowing eyes, suggested personal familiarity. Tanaka approached him carefully. "Excuse me," he said in English. "Did you work with these during the war?" The American turned, surprised by the question. "Yes, as a matter of fact. I was a torpedo maintenance officer on a submarine tender in the Pacific. Spent 2 years keeping these things operational." He extended his hand. "Frank Wilson." "Hideo Tanaka," he replied, shaking the offered hand. "I also worked with torpedoes during the war, though on the opposing side." Wilson's eyebrows rose, but his smile remained friendly. "Is that so? Well, I'd say we both know a thing or two about these beasts then." They stood together for a moment, 2 former adversaries united by their technical understanding of the same weapon. The war that had once divided them now served as a shared reference point, a common experience despite their different perspectives. "They were remarkable weapons," Tanaka finally said. "We learned a great deal from examining them." Wilson nodded. "We were pretty proud of them, especially the acoustic homing models, changed the game completely." He glanced at Tanaka with sudden curiosity. "Did you ever encounter them directly?" "Yes," Tanaka replied simply. "They taught us an important lesson about American capabilities. And now look at us." Wilson gestured around the exhibition hall where Japanese and American technologies were displayed side by side, competing and complementing each other in the peaceful marketplace of global trade. "I drive a Toyota, and you probably have an American television set," Tanaka smiled. "The world has changed considerably. For the better, I'd say." Wilson offered his hand again. "Good to meet you, Mr. Tanaka." As they parted ways, Tanaka took one final look at the torpedo that had changed his understanding all those years ago. The Mark 14 had been designed to strike ships, but its most profound impact had been on perceptions, revealing capabilities that contradicted assumptions and forcing a reassessment of what was possible. In that sense, perhaps the greatest power of technology was not its direct application but its demonstration effect, showing what could be achieved and challenging others to match or exceed it. The quiet revolution in manufacturing that the torpedo had revealed continued to reshape the world long after the weapons themselves had fallen silent. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II and check out the video on screen for another incredible tale from history. Until next time.